The sections on 3.4 is solving rational equations and radical equations as well. So I'm going to give two examples. One example is going to be on the rational, and then the other one is going to be on the radical. So when we talk about rational, it's going to be equations that have fractions format. That's going to be the rational part of it. And then the radical is going to be the one that has a square root of it. Okay? So let's go and start off with the rational one. So in the rational equation, what you want to do is look for the lowest common denominator, the LCD. So whenever you're given something like this, you want to break down the fraction part of it and see what they have in common and what they all need in order to make it a common, lowest common denominator. So for example, on this one, I have is x squared plus 9 or minus 9 right here. So let's go ahead and do the binomial factoring for that part. So we have then is x and x. We have a plus 3 and a minus 3. Because if I distribute this right here, I'm going to have is x times x gives me x squared right here. The plus and the minus will always cancel out the middle term. That's when you know that you are always going to do a plus and minus to cancel out the middle term. And then 3 times 3 should give us 9, but make sure it's positive 3 times negative 3 gives us negative 9 right there. Okay? With this one right here, this is the lowest, so there's nothing I can do with this one. This is also the lowest as well, so there's nothing I can do with this one. So within the 3 different fractions, or the denominator of the 3 fractions right there, we're looking for is what is the lowest that they all share that we can use to cancel out the fraction. Because the goal of this is to get rid of fractions. That's our goal. Okay? So probably the best one is going to be this right here, the plus 3 and the minus 3, because it is shared, the plus 3 and minus 3 on these fractions right there. So let's go ahead and do that. So then I'm going to have is x plus 3 and x minus 3. And what we're going to do is then we're going to take all of this and we're going to distribute that to each part of the fraction. So I'm going to take this and I'm going to distribute it to this first part of the fraction right there. Okay? Now I'm going to write this out and show the work so you can see. So what we have then is 2 over x plus 3 over here on this fraction, and then x minus 3, and I'm multiplying it to all of this part right here. So the multiplication looks something like this, the x plus 3, x minus 3, and this is technically over 1 fraction-wise, right? So we can see whenever you're multiplying, you always can reduce. So from here, this will cancel out right there, this will cancel out, and so you're left with is just 2 over 1, which is 2. So 2 is what's left over of this fraction when I distribute or multiply all of this to that fraction right there. So I'm going to go ahead and put 2 right here. Okay? Now doing the same thing with this 5, we're going to take 5, x minus 3, and this is positive 5 because it's positive from here. Okay, so that's the positive 5 right there. And I'm multiplying to all of this right here. So the x plus 3 again, x minus 3. And when we multiply it, the simplification can be canceled right here. So then you're left with is just the 5, the positive 5, and all of this part of the parentheses. So right here, I'm going to go ahead and put plus 5, and then x plus 3, that is left over right there. Okay? We have one more left then. So when I distribute this to this part right here, this fraction will then cancel out this fraction, right? Then I'm left with is just 3 on the top and x minus 3 as well. So because it's equals, we're going to go ahead and put equals 3, and then we said x minus 3 is what we have left over because the plus 3's will cancel each other out right there. Okay? All right, so we're here. So this is the best place to be at because now it's algebra. So from here, we're going to distribute, combine like terms, and solve for x just like algebra. So from here, then I'm going to take my 5. We're going to distribute to each parts of right here. So that's going to leave me at 2 plus 5 times x is 5x. 5 times 3 gives us 15 equals, and then same thing with this one. So 3 times x gives us 3x. Minus 3 times 3 gives us negative 9. So then from here we just combine like terms. So let's see, 15 and 2, I can combine those on that side. So that gives me 7 right there, 17 I'm sorry, plus 5x is equal to, and then we have is 3x minus 9. So then we can combine like terms. So since 5x is the bigger number right here versus the 3x, I'm going to go ahead and bring the 3x over on this side. So we have to subtract 3x on both sides. Subtract 3x. So we're left then on this side is 17, and then plus 5 minus 3 is 2, so 2x is equal to negative 9. So then we bring the 17 over, so we subtract 17 on both sides. And we're left with then is 2x is equal to negative 26, right? And then from there we divide by 2 on both sides, divide by 2, and x is equal to negative 13. So that's your final answer right there. Okay? So in the rational equations, we start off with fraction. Again, the goal is to get rid of that denominator of each of the parts of the fraction. So try to find the lowest common denominator that they all share. If you cannot find, or if you found something, and let's say you distribute it to each part, and you still have a fraction left over, then there's a problem because you didn't have enough to get rid of. So that means you would have to adjust this part right here, the lowest common denominator part. Okay? Now let's do the rational equation. So rational equation, our goal now is to get rid of the square roots. So in order to get rid of square roots, normally we would square it. But before we do that, I want to go ahead and talk about how to get rid of things. So whenever you're given this kind of problem, you want to make sure you do not have anything in front of this square root. Like usually it'll be like a number that you're multiplying by the square root, or behind it, outside of the square root, but behind it. So whether it be a plus or a minus, some kind of number out here, you don't want any of that business right there. Okay? If you do have those, then your goal is to get rid of it, right, by bringing it over to the other side of the equal side. So in this case, we don't have that problem, so we're good to go. So then we can then get rid of is the square root by squaring it. So we square it. So I'm squaring it because the power inside of here is 2. So when you do this, technically the square root is a half fraction-wise on the exponent. And if you do 2 times half, it's going to come out to 1. So that's why we do the square. So now in algebra, we always state that if you do one thing on one side of the equal sign, you have to do exactly the same on the other side of the equal sign right there. Okay? So that square is going to cancel out the square root. So then you have is 3x plus 3 on this side right here equals. Then you have is this x plus 1 squared. So you have to then write it twice, right, the parentheses, and you're going to have to distribute or FOIL it. So then we have is 3x plus 3 is equal to, and so x times x gives us x squared. X times 1 gives us 1x. 1 times x gives us 1x. And 1 times 1 gives us 1 right there. Okay, so we just continue on and combine like terms. So 3x plus 3 is equal to x squared plus 2x plus 1. So whenever you have now in this situation a x squared, that means this is a quadratic equation. So I would have to bring everything on this side of the equal sign over to this side, so that way this side is equal to 0. And so once we go to 0, then it's like the previous sections. We have a quadratic equation, you have to solve for it. So you can either complete the square or do the quadratic formula to finish that problem right there. So let's bring things over. So I'm going to subtract 3x and subtract 3. So underneath the right places, so underneath the x's, I'm going to put that negative 3x. Underneath this 1, I'm going to put a minus 3. So that way on this side, we have a 0 equals x squared. And then it's 2 minus 3, which is negative x. And then 1 minus 3, which is minus 2 right there. Okay? So again, this then becomes up to you, the algebra of how you want to solve for this. So let's see, I'm going to use the big x method right here. So the x method says this is a times c. So in the case, a is 1 times c is negative 2. So 1 times negative 2 is negative 2. And this is going to be the b, which is negative 1. So number combinations for negative 2 is what? 1 and 2. That's the only thing you have. So 1 and 2. So somehow I need to come up with a negative 1. So if I go negative, positive, that will give me negative 1. And then also if I multiply those together, that should give me negative 2. So we're good right there. Okay? If this didn't work, then I would have to definitely use the quadratic formula or completing the square. Because again, that option always works, where it is this finding the roots by doing the big X method or the binomial factoring does not always work. Okay? So let's go ahead and put this in the parentheses now. So then I have is x, and then this is plus 1, so we go plus 1, and then this is minus 2, so x minus 2. And then I have to go back and make sure I find the a. So in our case, a is 1 right here. So 1 right here, 1 right here. It's not going to affect this problem right here, but if I had a number right here for a, I definitely have to put it here when I set this equation equal to 0 and solve for it. So set it equal to 0. So then I have is x plus 1 is equal to 0. X minus 2 equals 0, x equals negative 1, and x equals positive 2. Okay? Now, with the radicals, you have to also be careful is to find out if both of the solutions work. Because in some cases, one of the solutions may not work, or both of them may not work. So you have to go back and then substitute it to see if it works. So we're taking this x right here, and we're going to substitute it back into the original equation right there to see if it works. Okay? So here's checking the work. So checking for x equals negative 1. So then my equation is the square root of 3x plus 3. And the question is that equal to x plus 1? So since x is negative 1, I'm going to go ahead and substitute that in. So it's 3 times negative 1 plus 3. And then equals negative 1 plus 1. Okay? So this right here is negative 3. Negative 3 plus 3 is 0. Square root of 0 is 0 is equal to. And on this side right here is going to be 0. So it checks. So then this one works. So this is a solution right here. Okay? Next, try the next one. X equals 2. So x equals 2. Same thing. We're going to take the same equation right here. So I'm going to go square root of 3 times 2 plus 3, and the question is that equal to 2 plus 1 right there? So that's 6 right there. 6 plus 3 is 9. Square root of 9, right? And this side right here is 3. So it checks because 3 is equal to 3. So actually both of the solution works in this case. Okay? So that's going to be the section that we covered on. And so continue then to practice on that problem.